Now on to covalent bonds, using Lewis dot structures to represent covalent bonds. Covalent bonds involve the sharing of electrons. So now we actually get to start connecting some dots, since my electrons are not actually being transferred from one atom to another. This first method I like to call the jigsaw method, because we are going to fit our atoms together as if they were pieces of a jigsaw puzzle. So I chose methane, carbon tetrahydride, CH4, for our first example. Just for bookkeeping's sake, let's draw the individual Lewis dot structures first. So carbon, as we know by now, has 4 valence electrons, 4 electrons in the s and p orbitals of the outermost ring. 1, 2, 3, 4. Now, electrons are more energetically stable, if you will, when they have a buddy. So I have 4 unpaired electrons here. That's 4 electrons that are going to be looking for that special someone, a buddy. My hydrogens each only have 1 valence electron. And as we mentioned before, it does not matter where I put that 1 electron. In fact, I'm going to have to move it around as I try to pair each of these unpaired electrons on this carbon. So I'm going to have 4 of these hydrogens on my carbon tetrahydride. So let's go ahead and start clicking these together. So I have one space here where I have no electron. Here's another one, and another one, and another one. All 4 of these need a buddy. So my first hydrogen, I'll go ahead and use this shape here. So my hydrogen with his electron is going to fill that empty hole right there, just like a puzzle piece, right in there. That takes care of 1 of my 4 hydrogens. I got to do all 4. There was 1. If I put my hydrogen down here, now I need my single electron to be on the top to fill that hole up top. So again, hydrogen, 1 electron, just like a puzzle piece. Over here, hydrogen means I need my lone electron on the left, 1 more up top. Now each of my electrons has a buddy. Since I'm sharing electrons, that means that simultaneously my electrons are spending some of their time around hydrogen. He's one of our exceptions. He's good with 2 electrons. Carbon has 2, 4, 6, 8, and all 8 of those electrons spend a good part of their time buzzing around this carbon, giving him a full octet, which is the driving force behind all of our atoms. That's why they bond, trying to get that full octet. I went ahead and drew the dots end to end like this so that I could also show you the structural formula. When we connect the dots, so 2 dots together like that, if I turn them into a line, now I have what's called a structural formula. The close cousin to the Lewis dot structure. All I did was connect the dots. Last thing, let's double check. Do all of my atoms have their full octet? My hydrogens are good with 2. Carbon has 8. They're good. Is my atom symmetrical? It sure is. Atoms love symmetry. Have all of my atoms been used in my structure? 1 carbon, check. 4 hydrogens, 1, 2, 3, 4, and we are good to go. Let's try water. Good old H2O, dihydrogen monoxide. So just like before, let's start off by drawing our Lewis dot structures for each atom individually. I'll go ahead and keep hydrogen in pink. He has 1 valence electron. My oxygen has 6. So I have 2 sets of paired electrons and 2 unpaired electrons. Where those are, again, does not matter. We can shift them around kind of however we need to. So I have 2 of those, 1 of those. My hydrogen can't make enough bonds to link all of those together, so I'm going to draw my oxygen in the middle. I'm going to rearrange my dots just a little bit so we get everything nice and symmetrical with those hydrogens off to the side. So here's one place that I need another electron to make a pair. Here's a second. So I'm going to take my hydrogen just as is and click him in just like a puzzle piece. This one on the other side. Now I need my lone electron on the left. We can connect it into a structural formula by connecting the dots. Let's think about our structure here for just a second. Gosh darn it, my screensaver came on. Pretty flower though. So my oxygen has 8 valence electrons. 2, 4, 6, 8, since the bonds are simultaneously, or excuse me, spending a good part of their time around the oxygen and then spending some of their time around the hydrogen. Hydrogen is good with 2 valence electrons, so he's happy. Again, we have the symmetry. All is right with the world. Let's try something that involves double bonds, something slightly more entertaining. How about O2? Oxygen is one of those atoms that does not like to be by itself. It's either going to be bonded to another atom or, bonded to another of the same atom. So, my oxygen has 6 valence electrons, and I'm going to have 2 of those. Let me draw it a little bit bigger over here on the other side. 2 paireds, 2 unpaireds. Do my second oxygen in a different color, and we'll do green this time. Oxygen, 2 paireds, 2 unpaireds. So, I have 2 places on each oxygen where I need a buddy. I need one here, one here, one here, and one here. Well, luckily, these 2 electrons can bond together, each becoming the pair that the other needed. I still have unpaired electrons on my oxygen, means I'm not quite finished yet. I can pair them as well. To neaten up that picture just a bit, let's redraw it. There's my pairs. Here's my 2 lones, my 1 from the side and my 1 from the bottom. My other oxygen had a pair on the top and a pair on the side as well. Here's my 1 from the middle and my 1 from the bottom. They are pairing. Connect the dots for a structural formula. So that's 2, 4, 6, 8 electrons around one oxygen, 2, 4, 6, 8 electrons around the other oxygen. It is still symmetrical. All my atoms have 8 valence electrons, and I have no electrons left unpaired. Good to go. One more that I would like to show you involves a triple bond. So let's do N2. N2 is also a diatomic. Doesn't like to be by itself, needs either another atom or another nitrogen to bond with. Nitrogen has 5 valence electrons, so there's my first nitrogen. Here is my second. So we're going to try to pair all our unpaireds and get these atoms to 8 valence electrons each. These 2 can pair right here. I still have unpaireds, so I'm not finished yet. There is another set of electrons that we can pair. Notice we're making sure to pair an electron from each atom. I cannot pair electrons together from the same atom. We have to bond to another atom. And this last guy is going to bond as well. To redraw that a little bit neater, we've got our 1 set of pairs at the top. Here's my 1 from the middle, 1 from the bottom, 1 from the left. My other nitrogen here had 2 on the top as well. 1 from the middle, 1 from the bottom, 1 from the right. And those 3 can bond together. 8 valence electrons around each nitrogen. It is symmetrical. I have no unpaireds left. Looks like a pretty good structure to me. If you have any further questions dealing with Lewis dot structures and covalent bonding, make sure you send me an email or leave me a comment down in the box below, and I will get back to you as soon as possible. In the next video, we will cover NOS, which is just another way of doing this same format. See you then.